Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone, this is Mostafa Shaikhoun and I'm gonna be with you in ELV Systems Fundamentals course. In the previous video we talked about an introduction to light current system. What are light current systems, what do they consist of, what do we gain from them, and who will take this course, and we knew that we are starting from the scratch. Today gonna be the first chapter of the course. We call it Basics of Electricity. Actually, we are not gonna study distribution or big things, just we gonna know what does mean electricity. So in this lesson, we're gonna learn the principles of electricity. Before we start the definition of electricity, I wanna tell you a short story. Inshallah, when you start a large project, you will have a dedicated room in the building. It's especially for you and your systems. We call it data room. That room we collect all ELV systems inside. It has the switches, the routers, the switchboards, the recorders, and so on. So these devices need to be powered. We need to feed these devices with the power, right? So I have to calculate the power that system needs. So first thing, before we start in the course, we have to know how to estimate the loads. Before you learn anything, you have to know how to estimate your loads. To prepare your reports, to give it to the MEP engineer, to be considered that how many power you need. Also in the small project like a farm, like under construction site, or somewhere in desert, there is no services, there is no electricity, there is no Etisalat service, and they ask you to install any of these systems. For example, they ask you to install a CCTV system in farm or desert. There is no power, there is no Etisalat services. So first we have to know how to calculate our loads. For example, how many DVR, how many bulb, how many charger, how many fan, how many AC, and we have to think about providing power for this system. So in this course we're gonna learn also, after electricity principles, how to build solar energy system. But before we start learning solar energy systems, we have to know how to calculate our loads. To make our calculation, to check how many solar panel need, how many battery, how many inverter, to help these systems to power down. So before we start in our course, and before we start in the solar system or any ELV system, we have to know how to calculate our loads. All of these things need to be estimated, so that based on these estimates you can calculate the solar energy system you need. So now we know what are we going to do now and what do we gain from it. Let me repeat what are we going to study. We are not gonna study distribution of electricity, we just going to learn the basics of electricity. But before I analyze the electric circuit, I have to know the definition of electricity. What does mean electricity? No need to make things bigger, so I have to say that electricity is a flow of electrons moving in one direction within a conductor. Flow of electrons moving in one direction within a conductor. What does mean? Conductor is similar like the wire. Let's see of this electric circuit. I have load, I have conductor, I have a generator here. So the conductor here is the wire. The wire has the flow of electrons. And what does mean electrons? Electrons are one of the elements that formation the atom. Okay, so what does mean atom? Atom is one of elements that formation matter. The matter is tangible things. The matter is tangible things. So I have a matter, it consists of atoms, the atoms consist of electrons. Actually, the atom is not consist of electrons only. but it consists of electrons, protons, and neutrons. As I see here, the electrons has a negative charge, and the protons has positive charge, and the neutron is a neutral. So these three elements form an atom, and billions of atoms form a mirror. So this was a simple definition of electricity. So now we have to analyze the electrical circuit. So electrical circuit is consists of load and conductor and generator to generate the power. In this example, we have a battery. The generator here is a battery. Let's analyze or scale an electrical circuit. Do you need to remind yourself why we scale it? To estimate the loads. We're gonna scale the circuit to estimate the loads. The loads we will tell the electrical engineer or EMB engineer to provide us for our systems, or the loads we have to calculate our solar system to feed in. Before you calculate or estimate the loads, you have to understand the law of power. We have here one law, we call it law of power. We have to understand first to know how to estimate or calculate the power in the circuit. This law, it defines the relationship between voltage, current, and power. Voltage, current, and power. So I'm sure that you heard before what you heard current, you heard the amps. So I'm gonna explain you what does mean the watt, power, the current, and the amps. So first, don't forget this triangle, and we have one T inside. At the top we have the power or the watt. Below we have the V or voltage, and I amps or the current. So top P, below V, and I. Don't forget this triangle because this is gonna help you to get the relationship between the watts, the volts, and the amps. In this example, we have one electrical circuit that consists of a bulb, conductor, and a battery. For example, I need to get to know how many watts this bulb, but it's not written on the bulb. No one tell me how many watts this bulb, but I have the voltage. I know it's working in 12 volt, 220, 100 volt, and I know the amps. I know how many ampere it takes. So it's easily to get to know the watts. You have to cover these parts and multiply the volt by the amps. To get to know the power, you have to cover the power and multiply the voltage of the circuit by the amps of the circuit. If I have the power of that bulb, let's say 5 watt, 50 watt, and I have the amps, and I need to get to know the voltage of the circuit. I have to cover the voltage and divide the watts by the amps. Let's say again, if I have the watts or the power of the load, and I have the amps of the load, and I need to get the voltage, I cover this port and I divide the watts by the amps. I will get the voltage. So if you need to get port, just to cover it and use the law to divide or multiply another parts. Here, if you need to get the power, you have to multiply the volt by the amps or the current. If you need to get the volt, you have to divide the power by the amps or the current. If you want to get the current or amps, you have to divide the power by the volt. I say it's very simple and you never forget this triangle. So now we're gonna know what does mean voltage. Before we understand that definition of electricity, and we said it's a flow of electrons moving in one direction within a conductor. So what does mean voltage? Voltage is the driving force that drives current through a wire. We have a current need to be driven, so the voltage is the one who force and drive the current through a wire. The power source, which consists of two poles, one negative and the other one is positive. As we see here, this is the generator and that one who generate the voltage, and we have two poles, one positive and one negative. So the unit of the measurement volt is V. We always say this battery 12 volt, 24 volt, and so on. And we understand that how to get the volt. If you need to get the volt, you have to cover the volt part and divide the power by the amps. We have one tool here, it's called multimeter. We use this device or this multimeter or voltmeter to measure the voltage. How we use this device? We connect one end to the positive and one end to the negative terminal. The red one with the positive and the black one with the negative. So that was simply the volt. Now we're gonna talk about the current. So what is the definition of the current, or what does mean a current? Simply the current is the amount of electricity or charge passing through a wire, and we use the symbol A to the measurement, or we define that with a letter. So now you know the current is electricity or charge passing through a wire, and the measurement unit is amp or ampere. So if I need to calculate it, I have one example here. Said I have a 200 watt bulb operating at 220 volt. So we use the triangle and cover the amps or ampere and to divide the power by the volt. Here the power is 200 and the volt is 220, so it's gonna give me 1 ampere. It's very simple. If you need to get part, you have to cover it and use multiply or divide another parts. One more example, I have a water heater 1000 watt and it's operating at 220 volt. So let's say 1000 divided by 220 equal 4.5 amps. Also we use the ammeter to measurement the amps or the current in the circuit by use it in open circuit. Before in the voltage we put one pole to the positive, one pole to the negative in closed circuit, but here we should open the circuit like this. We have the generator, we have the conductor, we have the loads, and one pole here in the beginning of the circuit and one pole in the end of the circuit. This is how to measurement or calculate the current. Now we have to know what does mean wattage or what does mean power. Wattage is the amount of the power consumed by devices. The unit of measurement is watt. How to get the watt or the power? By multiply the volt by current. If I need to get the power, I have to multiply the volt by the current. This is how to calculate the power. As I said before, if you need to get the power, you have to multiply the volt by the current. I have one example here. It says I have 220 volt and 5 ampere. So it's gonna be equal 1100 watts. So if I need to get the watts of the loads, and I have the voltage that I know 220, 110, 12, 24, I have to multiply by the amps. So it's gonna give me the watt. So here we're gonna know the difference between DC and the AC. Let's start with the AC. AC is abbreviation for alternating current. DC is direct current. In the direction, the AC it changes periodically. It goes and returns. But the DC is constant in one direction. The AC, it's a common source is a public electrical grid or household electricity. But the DC, the common source is the batteries, solar panels, some inventors. This is how we get the DC and the AC. The voltage AC is continuously to 20 volt or 110 volt in the homes or some countries. It depends on the country. There is some countries similar like Egypt to 20, one country similar like Saudi Arabia 100 volts. But the DC is changed slowly. We use the AC in the large applications such as air conditioner, washing machine, lighting, and so on. But we use the DC in electronics, similar like mobile phones, laptop, devices with microelectronic circuits. Let's see the sine waves of the DC and the AC. As we see here, the AC or alternating current, it's same like a sine wave. It's a sine wave. But here in the DC, it's direct current. See, when you see this line, you have to know that it's DC, and if you see this sine wave, that means it's AC current. So this was simply the difference between AC and the DC. Some difference in wattage, or let's say that when you hear kilowatt, you have to know that kilowatt equal 1000 watts. This is a small unit suitable for household electricity consumption. When you hear megawatt, that means equal 1 million watts. Gigawatt equal 1 billion watts. Terawatts equal trillion watt. It's trillion watt is a unit suitable for a country electricity production. And here in this paper I have some symbols in Arabic. I wish I could to publish in English, but I right now I don't have. So when you see this symbol, it means single switch, is double switch. This symbol is means there is a bell. This is power socket. This is normal socket. This is TV outlet. This is a television outlet. WH, it's water heater. AC means air conditioner. When you see the symbol in the drawings, that means it's a control panel or electrical panel. And this symbols means a bulb. There is a bulb in the drawing. And when you see the symbol, means there is a solar panel in the drawing. So I think we finish the chapter of electricity principles or fundamentals. Now we have Q&A. First question is, the unit of measurement for voltage is amps or ohms or volt or watt? No, the correct answer is a volt. So the voltage, we use the volt measurement unit. Question number 2. Direct current or DC is often used in air conditioners, home lighting, batteries, washing machine. We said before the DC we use with batteries, we get it from the batteries. We use it with electronics devices, same like cell phones, laptop, and so on. Question number 3. Electrical power is calculated by, if we need to get the power, what we do? We multiply the resistance by voltage, or we divided current by voltage, or we multiply the voltage by current, or we divided the voltage by current. We said if we need the power, we go to our law, we cover this part and multiply the volt by amps. Let's see the correct answer. We multiply the volts by current. Here, if the voltage is 12 volt and the current is 2 amperes, then the power is, we have here the voltage 12 and the current is 2. So the watt gonna be, I have to go to my triangle. I say 12 volt divided by 2 amperes. Let me bring this one here. Put it here. see you have 12 volt and you have 2 amperes. So the power gonna be multiply the volt by amperes, it's gonna give me 24 watt. So if we need to get the power, we have to multiply the volt by ampere. If we need to get the volt, we have to divide the power by ampere. If we need to get the ampere, we have to divide power by volt. Now I am خلاص finish the fundamentals or principles of electricity. In the next lesson we're gonna talk about PV system or photovoltaic or solar systems.